So hi everyone, we are going to have math, like I've mentioned. Now in math, we already started looking at sets of numbers, and on sets of numbers, we did describe difference of sets of numbers. Let me just quickly mention them. We have the set of natural numbers. We also have the set of uh, whole numbers. We have the integers, and then from integers, we have the real numbers. Sorry, not the real numbers. We have the rational numbers, and then we also have the irrational numbers. We have the real numbers and the complex numbers. Okay, so we already discussed on the set of natural numbers, whole numbers, and integers. Now we want to look at the set of rational numbers. Okay, so we look at rational numbers. So the set of rational numbers. Now, by definition, I think we already started looking at this. By definition, we said that number one, how do we define rational numbers? We said that a rational number is a number that can be written in the form a over b. Okay, where this a and b are integers, right? Then b should not equal to 0, because once it is 0, it's going to be undefined. And what else? We're saying that a and b should not have any common factor other than 1. Okay, other than 1. So what it means when we say should not have any common factor other than 1, it means that a over b should be in its lowest terms, right? It should be in its lowest terms. A and b, a over b should be in its lowest terms. That's what it means. All right. And then the second definition that we discussed is that a rational number. So let's give examples, by the way, before I give the second definition. Example, we can say, let's say 1 over 2, let's say 3 over 4, we can have 4 over 5, we can have 7 over 6, right? We can have, let's say, 10 over 9, right? We can have even 5, okay, because you know that 5 is the same as 5 over 1, okay, and so on. All those are rational numbers. Then the second definition we talked about is that a rational number is a number. So I'm being a bit quick because we already discussed that. Is a number that has okay a repeating and non-terminating decimal. Okay, a repeating and non-terminating decimal. So what it means is that the same decimal is repeating itself over and over, and then it's not coming to an end. Okay, it's just coming up and up and up without coming to an end. So we have an infinite number of decimal places. All right, we have an infinite number of decimal places. Now those decimal places are occupied basically by the same number, the same decimal, which is repeating itself over and over. So an example, we can say, let's say 0.3333, and so on. It keeps coming up, the 3 keeps coming up and up like that. All right. Even when we look at the numbers such as 0.66666 and so on. All right. If we look at a number such as 0.144 4, so the 4 is repeating itself and so on, right? Now this one can also be written as 0.3, and then we put a little dash on top there, on top of the 3. This one can also be written as 0.6 with a little dash on top of 6. This one also can be written as 0.4, I mean 14, but the dash is only on top of the 4. And then we can also have a number such as 2.5, 1, 2, 1, 2, 1, 2, and so on. So in this case, we are having 2.5, and then 1, 2 is the one which is repeating itself, right? So we can have all those numbers as rational numbers. Now let's look at how we can convert these rational numbers, which are in form of decimals, to form what? Fractions, right? Now, remember, we've already defined that that a rational number is a number that can be written in the form a over b, okay? In the form a over b, or we can also say that a rational number is a number that has that has repeating and non-terminating decimal. So, meaning that we can convert between these two forms of rational numbers, right? We can convert between those two forms, between a fraction like that and decimals. So how can we convert those? All right, how can we convert those? So there's a way in which we can convert each of those. Is everything okay? Are we all safe? Are we okay there? Hello? Are we following? Okay, so I was a little fast, but now I'm going to slow down a bit because what I was trying to explain was more like a recap of what we did last time. But now I'm going to slow down a bit so that you guys can properly understand. So now we're saying that let's look at an example. We say example 1. Write the following in the form a over b, where b is not equal to 0, then a and b are integers, right? And a over b should be in its lowest terms. Okay, should be in its lowest terms. By the way, it's very important for you to take note of the definitions that we've given, because those are the definitions that are going to help us understand what are called irrational numbers, right? So now, I'm just going to give these same examples that I listed down here. So this is going to be my A, this is A, B, C, and this is D, right? So that's what we're going to have. So we write each of these in the form a over b, where a over b should be in its lowest terms and b is not equal to 0. Then a and b are actually integers, right? So now how do we go about that? The first part, we say part A, right? So we have, this is 0.3, which is also the same as 0.3333, and so on, right? So we say that's the first step. We say let x actually equal to 0.3333, like that. And then we can call this one as equation 1, okay? And then what we now do is that, now I want you to notice that, I want you to take note of these two terms. There is what is called the first, okay, the first repeating decimal, okay, first repeating decimal, and what is called the next repeating decimal, okay. Now we have to move, either we move the point to the decimal point to the first repeating decimal, and then we move it to the next repeating decimal. Now if it's already at the first repeating decimal, we just have to move it to the what? To the next repeating decimal. Now how do we do that? So in this case, I want you to take note of this. In this case, the decimal point is already at the first repeating decimal. The first 3 there is the first repeating decimal, and then the second one here is the next repeating decimal. Okay, so we notice that the decimal point is already at the first repeating decimal, right? So meaning that we have to move this point to the next repeating decimal there. So that's what we need to do. We have to move it to the next repeating decimal. Now, how do we move it to the next repeating decimal? You can see that this is only one decimal place that is being crossed by the decimal point, right? So for us to move it there, it means that we have to multiply this whole number by a 10. Now, what we do on the right-hand side is what we do also on the left-hand side, isn't it? So we want to move this decimal point to here between the first 3 and the second 3 of that number. All right. So we're going to say that we multiply equation 1 by 10. Okay. If we multiply equation 1 by 10, what are we going to have? We're going to have on the left hand side, we're going to have 10x is equal to, and then since we're multiplying by 10, it means that this decimal is going to move once going to the right. So we're going to have 3.3333 and so on, right? Like that. So what I want you to notice is that after we multiply by 10, what we are having on the left hand side, on the right hand side of the decimal point, all right, so we have the decimal point here, and then we have the right hand side of the decimal point. What we are having is those are the same numbers, the threes. Even in this case, we have all of them are threes like that. So once we reach that such a point, it means that we can now go ahead and subtract equation 1 from equation 2. Okay, because it means that once you do that, once you subtract, what you're going to have on the left hand side is going to be a 0. So let's go ahead and subtract equation 1 from equation 2. So we say subtract equation 1 from equation 2. All right, subtract equation 1 from equation 2. What are we going to have? So if we do that, it means that we're going to have 10x equal to 3.3333 and so on. And then we also have x is equal to 0.3333 like that, right? And then we subtract. Okay, so on the right hand side, what are we going to have? On the right hand side, we can see that 3 minus 3 is 0, 3 minus 3 is 0, 3 minus 3, 3 minus 3, all those are zeros. And then 3 minus 0, that is a 3. And then here we're going to have what? 10x minus x, that is 9x. Okay, so 9x is equal to what? It's equal to 3. And then how do we proceed from there? We simply, we want to make x subject to the formula, so we're going to say that x is equal to 3 divided by 9. But remember, we said that we have to express this in h lowest terms, so we're going to have x is equal to 1 over 3 by dividing both 3 and 9 by what? By 3, because 3 is the common factor between 3 and 9. So our x is equal to 1 over 3. Now, but we said that x is equal to 0. What? 3333, like that, right? So we already said that. So we can say, then therefore say that, therefore 0.3333 is equal to what? 1 over 3. Okay, so that is going to be our answer. That's how we wanted to convert that decimal number to a fraction like that, to a proper fraction. Okay, so is that okay? Are we okay with how to convert such a number to a proper fraction? Is it fine? Can we proceed? Okay, so I'm going to leave the second one, which is 0.666. with you guys because it's basically the same, exactly the same as the one that we're just from working out. So I'm going to go direct to the second one, right? I'm going to go to the second one and then I work out also the third one. And then from there we'll be done with rational numbers. Then what I'm going to simply do is that we're going to, I think we'll just switch to physics. Real quickly, I introduced vectors in physics. Not going to spend so much time there due to time. Okay, so the second one was, the third one, which is part C, was 0.1444, like that, right? It was like that. So now remember, I told you that you have to take note of what is called the first repeating decimal, okay, and the next repeating decimal. Okay, so in this case, what can we observe? We can observe that the decimal point is not at the first repeating decimal, neither is it at the second and at the next repeating decimal. Okay, so it's neither at those, right? So the first thing that we have to do is to move the decimal point to the first repeating decimal. So which one is the first repeating decimal? The first repeating decimal is the first 4 there. Okay, so we have to move this point to the first repeating decimal right here. Okay, so that's the first thing that we have to do. So how do we move that decimal point? One step to the right, isn't it? We are moving it one step to the right. So the only way we can do that is multiplying that number by a 10. Okay, so we are going to say that let x equal to, we can use any letter, by the way. You can use y, you can use b, you can use a, whichever letter, but I usually like using the letter x. Okay, so x is equal to 0.1444 and so on, right? And then what are we going to have? We say multiply, we say this is equation 1. Okay, we multiply equation 1 by 10. Okay, so we're going to have on the left hand side, you're going to have 10x is equal to, so we're moving it once because we're multiplying by 10. It's going to be 1.444, isn't it? All right, and then we can call this one as equation 2. Okay, we can call it equation 2. Now, at this point, what we can see is that you can see that what you have on the right hand side of the decimal, and in both equation 1 and equation 2 is different. So look at what you have on the right hand side of the decimal and what you have of equation 1, and the right hand side of the decimal of equation 2. Look at what you have. So they are totally different because here you have a 1, here you don't have a 1. So it means that you can't go ahead to uh, to 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 subtract there. Okay, you want to make sure that what you have on the right hand side, what you have this side, and what you have this side, they are exactly the same. All right, so what we do again, we have to move. All right, we have to get now another one. Okay, we have to get another one where we have to move the decimal point to the next repeating decimal. By the way, remember I said that you have to have the decimal point has to be moved first to the first repeating decimal, and then it is moved to the next repeating decimal. Once that is achieved, then we can go ahead with subtracting the equation that is having the decimal at the first repeating decimal and the equation that is having the decimal point at the next repeating decimal. That's when we can subtract. So the first equation, that the equations that we're subtracting is the one, we subtract the one with the decimal point at the first repeating decimal from the equation having the decimal point at the next repeating decimal. So this equation we have is having the decimal point at the first repeating decimal. So this is checked. Okay, that is checked. Now let's have the decimal point at the next repeating what? Decimal. Okay, so how do we move the decimal point to the next repeating decimal here? So we want to move it to there. So how do we move it there? Again, we can multiply equation 2 by 10. Okay, we can multiply equation 2 by 10. Or alternatively, I'm going to explain an alternative to that. So let's say multiply equation 2 by 10. Okay, by 10. Now, I want you to see that an alternative to that is multiplying equation 1 by 100, isn't it? Because if you multiply equation 1 by 100, let's maybe first work out this part. We said if you multiply equation 2 by 10, so if you multiply on the left hand side, 10x by 10 is going to be 100x equal to 1.44444. It's going to be 14 point what? 0.444 and so on, right? And then we can call this one as equation 3. Okay, that is equation 3. So that one is now having the decimal point at the next repeating decimal. Now, let's look at an alternative. Instead of multiplying by 10, equation 2 by 10, you can also multiply equation 1 by 100. Okay, you can multiply equation 1 by 100. Remember, equation 1 is x equal to 0.14444. So if you multiply on the left hand side, x by 100 is going to be 100x, and then 0.1444. So we're going to move the decimal point 2 times, 1, 2, and then it comes there. So it's going to be 14.444 and so on. So you can see that what you're getting is the same. That's the same thing that you're getting, isn't it? So then at this point, since you have one of the equations with the decimal point at the first repeating decimal, and then another equation at the next repeating decimal, then you can subtract the one with the decimal point at the first repeating decimal from the one with the decimal point at the next repeating decimal. Okay, so in this case, we are not going to use equation 1. We are instead going to use equation 2 and equation 3. So what we do, we say subtract equation 2 from equation 3. Okay, subtract equation 2 from equation 3. That's what we are going to do now. All right. So let's go ahead and do the subtraction. So equation 3 is 100x equal to 14 point what? 444 and so on. And then the equation 2 is 10x equal to 1.444. Okay, so if we subtract that, what are we going to have? Let's look at the right hand side of these equations. 4 minus 4 is 0, 4 minus 4 is 0, 4 minus 4 is 0, right? And then 4 minus 1, that is 3. And then here it's like there's a 0. Or rather, we can just say 14 minus 1, it's 13. Okay? And then 100x minus 10x, that is 90x, equal to that. So now we want to make x subject to the formula. So what we do, are going to say x is equal to 13 divided by 90. Now, can we have that? Is there any common factor between 13 and 90? Definitely not, because obviously already we know that 13 is a prime number, isn't it? 13 is a prime number. A prime number is a number which only has two common factors, rather, that is 1 and that same number. In this case, 1 and 13 are the only factors of 13. And we know that in the case of 90, it's only 1 which is a factor. So you can see that here the factors of 13, it's 1 and 13 itself, and the factors of 90, it's 1 and 90 itself. Those are the only factors. So what is a common factor? It's 1. Now we said that these two numbers should not have any other common factor other than 1, right? So it means that the only common factor there is 1. Okay, so it means that we are in check. That is okay for now, and we can't reduce it to its lowest terms. Now we said that, but we already said that x is equal to is equal to 0.1444, like that. All right. So therefore, 0.1444 is equal to 13 divided by 90. Okay. So that is the number that we are looking for. That's the number that we are looking for. All right. Can we go ahead and solve the third one? I mean the fourth one. Are we okay with that? All right. Perfect. It looks like Tina has left. Is it because of network or it's because of time? Sorry. How what? Okay. Let me just. Oh, the video pause. Oh, too bad. Maybe it's the network. All right. That's the only challenge with e-learning. It's especially in our setup where network is always a challenge here and there. All right, but I hope she's going to be able to catch up with the video after I post it on YouTube. Okay, so let's look at the fourth one. What was the fourth one again? Let's Okay, so the fourth one was 2.5, 2.5, 2.5, 1, 2, 1, 2, 1, 2, and so on. Okay, so again, as usual, we select x equal to 2.512, 1, 2, 1, 2, and so on, right? And then, so we should have the first repeating decimal and the next repeating decimal. Okay. So what do we have here? Do we have the decimal point at the first repeating decimal or not? I want you guys to tell me. Do we have the decimal point at the first repeating decimal or not? Sorry. Okay, Brenda, what do you think? Okay, so one says it's at the first repeating decimal, another one says it's at the next repeating decimal. Now, in this case, we should notice that the first repeating decimal is the 1, 2, the first 1, 2 there, all right? And then the next repeating decimal is the next 1, 2 here. Okay, so you can obviously see that it's neither at the first repeating decimal nor the next repeating decimal. Okay, so it's at 5, and 5 is not a repeating decimal. It's not repeating. 5 is not repeating, isn't it? So we have to move the point to the first repeating decimal. We have to move it here. Okay, we have to move it there, and then in our next step, we have to move it where? Here. Okay, so that's what it means. We first move it here. This is step 1, and then step 2, we move it to the next repeating decimal. Okay, are we together? So this one here, it's neither at the first repeating decimal nor the next repeating decimal. So we first have to move it to the first repeating decimal. How do we do that? There's only one step between where it is and the first repeating decimal, meaning that we multiply it by 10. Okay? So multiply equation 1 by 10. And what are we going to have? By 10. So what we're going to have on the left hand side, we're going to have 10x is equal to 25.1212. All right. Let me write that properly. 1212. Okay. And then, so we now have equation 1, right? We now have equation 1, which is having, this is equation 2, this was equation 1. Okay, we now have equation 2, which is having the decimal point at the first repeating decimal. Okay, at the first repeating decimal. Now, what do we do? What's next? What do we do next? Okay, the next thing that we do is to move the point to the next repeating decimal. Okay, to the next repeating decimal. Now, the goal that we want to achieve is that, remember, if you compare the two sides of the equation, equation 1 and equation 2, you have that and that, okay? So what is the difference between these two? You can see that there's a 5 here, while in this one there's no 5, okay? So that is what is making the difference, and you can't go ahead to subtract that. You can't subtract that, okay? Because you are going to have something, you don't want to remain with any decimals after you subtract, okay? So we move the point to the next repeating decimal, which is right here, okay? At this point here, that's why we move it to. Now we can see that there are two steps from where the point is to the next repeating decimal, meaning that we multiply that equation by 100. So multiply equation 2 by 100. Okay. Alternatively, we can say multiply equation 1 by 1000. Okay, it's going to give us the same thing, right? So let's multiply equation 2 by 100. Left hand side 10 by 1000, by 100 is going to be 1000x equal to 25.121212 is going to give us 2512, all right, 0.121212 and so on, right? Similarly, if we're multiplying by 1000, multiplying by equation 1 by 1000, so x by 1000 is going to be 1000x, right? Not so. And then 2.51212, it's also going to give us 2512.1212, and so on and so forth, right? So it's giving us the same thing. Okay, so you can, I would rather you stick to this, rather you stick to one method, which is multiplying the second equation by 100 in this case. Okay, and then what do we do? So this is equation 3. So we say subtract equation 3, subtract equation 2 from equation 3. Okay, subtract equation 2 from equation 3. So what we get, we're going to have 1000x equal to 2512.121212, like that. And then this one is 10x equal to what? Equal to 25.121212. Okay. So if we subtract, 2 minus 2 is 0, 1 minus 1 is 0, 2 minus 2 is 0, 1 minus 1 is 0, 2 minus 2 is 0, 1 minus 1 is 0. So on the left hand side, you're going to have all zeros. And then let's have this one here. Okay, so 2 minus 5, obviously can't, we get a 1 obviously from there. All right, so 12 minus 5, that is what? That's 7, right? 12 minus 5 should be 7. And then we're also getting a 1 from the 5, so we have a 10 here. So 10 minus 2, that is 8. And then you remain with a 4. So 4 minus 0, that is 4. And then here we have what? We have a 2. Remember, like I said, we don't use calculators in this mathematics. Okay, and then 1000 minus 10 is going to give us what? It's going to give us 990, right? That is 990x equal to that. Okay, then what next? We make x subject to the formula. So we're going to have x is equal to 2487 divided by 990. 90. Okay, I don't think that number there's any common factor between the numerator and the denominator. Okay, so we say that, but we already said that x is equal to 2.5121212, like that, isn't it? We already said that. So therefore 2.5121212 is going to be equal to 2,487 divided by 990. Okay, so that is our answer. So that's how you work out these questions. That's how you work out these types of questions. Okay, is everything okay, Tina? Oh, okay. It's good that it's fine. So I hope you'll be able to follow through the video later on once I upload it on YouTube. Yeah. Okay. Brenda has left. Has she sent any text in the WhatsApp group? Okay. So let me just quickly introduce vectors. I'll just give an introduction maybe in the next 10-15 minutes. Okay. So let me end this video here.